you've been a subscriber to my channel for a while now, then you may recognise this. It's my old S800 flying wing, which was once my favourite aircraft and was often featured in many of my early videos. Now regrettably, I ended up getting rid of it a couple of years ago as I moved on to bigger and more powerful aircraft. But recently, after seeing the kit on sale in Hobby King, I decided it was time to build another one, and here it is. Now this build is a lot better than the old one. The airframe has been upgraded from the black version 1 to the newer silver version 2, and many of the electronics are now smaller and more advanced. There's also 3D printed parts on this build, which is something I didn't have on the old one, and these have allowed me to make the build a little bit cleaner and hopefully also improve some of the flight performance. Now, as many of you will already know, on this channel I usually do step-by-step build tutorials for various RC aircraft, but as I've already done a S800 build tutorial a few years ago, this time around I'm going to do a build overview instead. So let's get to it. Starting at the front, in the nose, there are two cameras. On the right is the FPV camera, which is a Runcam Phoenix 2. I chose this camera simply because it has excellent wide dynamic range and low light capabilities, making it one of the best FPV cameras available at the moment. On the left there is then a Calyx Loris 4K HD camera, which obviously is there for recording flight footage. Now I'll talk more about that a little bit later. Both cameras are mounted in this specially designed 3D printed block, which as you can see not only securely houses them both together, but also provides cooling and SD card access. This block also provides nose weight for the aircraft to help get the CG right. This was done by carefully adjusting the infill percentage in Cura before sending it to print. To the left of the nose there is then this compartment. This houses the video transmitter, which is a TBS Unify Pro 32. The reason I chose this transmitter is simply because it can output over 1000 milliwatts, which should make it brilliant for flying long range. Now the only downside is it does get extremely hot, so as you can see I've attached a heatsink here which allows the airflow to provide some cooling. Obviously this does produce a little bit of drag, but that's preferable to having the transmitter shut down mid-flight. The antenna which is attached to the transmitter is a TBS Triumph Pro antenna, which may not be the absolute best antenna available these days, but to be honest it's what I had in my spares bin, so that's why I've used it. On the right hand side of the nose there is then a similar compartment, although this one houses the receiver. This is a TBS Crossfire Nano SE receiver, which is what I've used in all my builds, and again will be brilliant for flying long range. In the main compartment then is where the flight controller is located, which is in the Tech F411 wing. Now this is by no means the best flight controller available these days, but it's more than adequate for this build and its layout helps keep the wiring tidy. Now on the note of keeping things tidy, you may have noticed that this flight controller is installed in a 3D printed mount. I designed this mount specifically to help keep the build clean, and the way it does this is by routing the wires around the edges here through this channel, which is then concealed with a cover plate. The GPS unit for this build is hidden here. It's a Matech SAM M8Q, which is a brilliant unit and one that I've used on many of my previous builds. Now if you're wondering how it is I've managed to conceal it like this, all I did was first cut a hole and install the unit, and then I covered it over a piece of spare foam that I got from here. Moving to the back of the aircraft now, and you can see the motor here, which is a T-Motor F60 Pro 4 1950 kV. This is attached to a custom 3D printed mount that I designed, which allows you to easily take the motor on and off if you want. The motor is spinning a 7-inch prop, which is a very tight fit, but it does work and provides an awesome amount of power. On either side of the motor are then these small LED strips, and these can be programmed to be any colour that you want. The final electronics to mention then are the servos, which are Emax ES08 MD2s, and then the ESC, which is hidden under this 3D printed vent, which is a Littleby Summer 30 amp. Now in hindsight, this ESC should probably be a 35 or a 40 amp, as this build does draw a little bit more current on launch than I anticipated, but it works well enough, as you'll see a little bit later. Now you may be wondering why it is that I've installed hardware in the side compartments here when there are pre-made compartments in each of the wings already. Well, the answer to that is simple. Keeping weighty hardware off the wings and instead as close to the centre of gravity as possible increases the aircraft's stability and makes it less likely to want to rock around on the roll axis. Now, stability is also the reason why these 3D printed vortex generators are installed along the leading edges. Having them there improves handling at low speeds and helps prevent tip stalling. Now, as I've chosen not to use the stock compartments in the wings, I've concealed them using these 3D printed covers. The reason I've used these over the stock carbon fibre ones is simply because these have no holes in, so should produce less drag and hopefully lead to better aerodynamic efficiency. The total weight of this build is around 360 grams, and with a 2200 3S LiPo battery installed, the weight goes up to just over 500. In its current configuration, a larger battery won't fit, and although this can be remedied with the use of a 3D printed hatch, I've chosen not to do that as a 2200 battery is providing me with plenty of flight time. Now, this build has a lot more power than you might expect. At launch, when you throttle up to 100%, the aircraft is actually hard to hold down, and as a result, even a limp-wristed throw will get it climbing into the air with ease. As it launches, the current peaks at around 33 amps, which thankfully is within the 35 amp burst rating of my ESC, but is why I suggested earlier that a 40 amp ESC might be more suitable. Once in the air, this wing flies great. It'll happily cruise at around 35 to 40% throttle, which will result in a current draw of around 3 amps and a speed of around 20 miles per hour. If you're careful, flight times can exceed 30 minutes, which should allow for long range flights of around 10 kilometers out and back again to be achieved. Now, if shorter but faster flights is more your thing, then cranking up the throttle yields some impressive results. At 100%, this wing will nudge 100 miles per hour in level flight whilst drawing around 20 amps, and it will also climb almost completely vertically at a speed of around 10 meters per second. Now, the only downside to flying like this is obviously it does significantly reduce the flight time. At best, you can probably expect to only get around 10 minutes in the air. At this point, it's probably important to mention the sound. With that 7-inch prop spinning just millimeters from the edge of the airframe, this wing is extremely loud, especially at full throttle. If you wanted the wing to be a little bit quieter, putting a 6-inch prop on would probably help a lot. But the downside would probably be a loss in power and a reduction in the overall flight time. Now, before I wrap up this video, I want to quickly talk about the Caddx Loris HD camera in the nose. The reason I bought this camera is because it shoots 4K, but as you may have noticed, this video is only 1080. The reason for that is because what I've done is take the 4K flight footage from the camera and stabilise it in DaVinci Resolve. Doing this generates smoother looking footage, which is nicer to upload online, but the stabilisation process does reduce the video resolution. By recording the initial footage in 4K, I'm able to output 1080p stabilised footage, which looks decent. If the original footage was only 1080 to start with, then the stabilised footage at the end would be noticeably lower res. Now, you might argue that it would have just been easier to put a GoPro 7 in the nose, so I could have just used Hypersmooth to get the stabilised footage. And you wouldn't be wrong for saying that, and I did consider it. But not only is the GoPro a lot bigger and harder to cleanly install in an S800, it's also a lot more expensive than the Caddx Loris, and so that's why I didn't use one. So some of you may think I'm crazy for saying this, but I honestly believe the S800 is one of the best aircraft you can buy. Sure, it may not be the fastest or able to fly the furthest, and it's not made by a brand that's especially worth bragging about. But what it is a lot of fun to fly, and out of all the aircraft I've ever owned, it's probably the one I've enjoyed the most. If you like the look of this build and you want to build one yourself, here's a wiring diagram to help you out, and I've also included links to the 3D print files in the video description. I hope you've enjoyed watching this video, and if you have any questions, feel free to ask. Please consider giving this video a like, and until next time, see ya!
Oh, landed. Damn.